All right, in this lesson, we're going to be focusing on a few things, translating some real-world situations into equations or inequalities, and then solving and graphing them on a number line. The one difference today is that we're going to be looking at one-step inequalities and talking about how to solve those. So you'll see what I'm talking about a little bit later in the lesson. So let's quickly go over the answers to the do now. So go ahead and turn to that page. All right, if we take a look at each of these questions, first of all, B should not be greater than or equal to 20. It should be less than or equal to 20. All right, so keeping that in mind, we have 6 gallons. For every hour, we're going to use 6 gallons. So we need to multiply those together to determine how many gallons we use for a certain number of hours. And we only have 20 in the tank, so we have to be less than or equal to that, or we're going to run out of gas. But an hour is like each, so we know it's a multiplication situation. In number 2, we have, she wants to sell more than 20 ice cream cones. So more than is going to be just greater than, plain old greater than. She's already sold 6, and then we need to know how many more she needs to sell. So it's going to be some unknown number plus the 6 she already sold needs to be greater than 20. That's what we're going to be spending some time doing today. All right, these two problems were just to demonstrate that solving an equation is pretty much the same as solving an inequality. You still undo the operations with the inverse, you still balance, and we're going to do a little bit of practice with that today as well. All right, let's just take a quick look at the homework answers. All right, I need to do the graphs for these. So for B, n is less than or equal to 6. So I'm going to have a big dot, and I know that we have to go below that, like that. W is less than 3, so that doesn't include 3, and again, less than is below, like that. And D is G is less than -1. That doesn't include -1, and again, less than means below, which means to the left. And then finally, M is greater than 4. Again, that is an open circle. Greater than means above, and above goes to the right. And for these, you may have had slightly different answers because these circles aren't quite exactly on the numbers, so you might be really close to what I have. So I thought this was close enough to 1 that maybe it was meant to be 1. This one is kind of close to 4. This one I thought was a little bit below 70, so I said it was 68. And this one I thought was a little bit below 8, so I said 7. But if you had something close to these, then you're probably in good shape. All right, turn the page, and we're going to get started looking at some examples. So I want to do a couple of examples of this process of translating, solving, and graphing. So let's take a look at this first problem. Marco wants to spend at least $8 on a gift. All right, so this is a pretty simple inequality, and there's a couple of important words here. So first we see at least. And we learned in yesterday's lesson that means something special. That means that it's going to be greater than or equal to. So again, this is a short type of inequality. We know that the inequality is going to be, I'm going to use the letter M, and the amount of money that he spends needs to be greater than or equal to 8. At least 8 includes 8 and above. Now we're going to graph that. But notice that this graph does not have any numbers on it, okay? But that actually makes it easier. You're going to pick one of the marks, and you're going to label it with our starting point. So since I'm doing greater than, I'm going to pick something a little bit on the low side. I'm going to pick that mark. And I need to graph greater than or equal to 8. So I'm going to label this mark as 8. And then I know that greater than or equal to means it's a closed circle, and it has to go above 8. That's what greater than means. Something like that. So we're going to be doing a lot of this where you label the graph with the right number to represent it. All right, now let's take a look at a one-step problem. Notice there are really no steps in this, right? M is greater than or equal to 8 is very simple. We graph it, we're done. Here we're going to have to do a little bit more work. So let's take a look. Marco wants to buy 3 pizzas, but he can't spend more than 30. Write an inequality and determine the most he can spend on each pizza. Okay, so again, we have some key words here, right? More than. And again, we learned what that meant yesterday. He can't spend more than 30. That means he has to be less than or equal to 30. He can't spend 31, he can't spend 32, but he could spend 30 and 29 and 28. But he is buying 3 pizzas, okay? So this is the total for all of the pizzas. Each pizza's the same cost. He's ordering the same pizza. So we know that 3 of the pizzas he has to spend less than or equal to 30. So he's buying 3 pizzas. So 3 pizzas at some amount of dollars each. And this will let us determine, what kind of pizza he can get. It might be just plain pizza is all he can afford. Pepperoni pizza is going to cost more for each pizza, so that might be too much money. So we're going to figure out how much he can actually spend on each of these pizzas, and that's what P represents, is the amount, right? P equals dollars. All right, so possible solutions. So can he spend $10 per pizza? So that'd be 3 times 10 is 30. So absolutely, you can spend 30, you can spend 10. But he has to be below that, so what else could he spend? Could he spend $9? Well, 3 times 9 is 27. 27 is less than or equal to 30, so he could spend 9 as well. Or 8, or anything right below 10 is fine. But let's think about an algebraic solution. So let's write our problem again. We're looking at 3p less than or equal to 30. And like we did in the do now, we can solve this just like we solve a normal equality. I'm going to divide by 3 and balance it. So I'm going to get p. And what's important is that you bring down the exact symbol. So we know that the amount he can spend on pizza is going to be less than or equal to $10 for each pizza. So I'm going to mark that. I'm going to pick this mark here to be 10. And it's less than or equal, so I know it's a big closed circle. And less than means below, and below means shade to the left. All right, so again, this was a one-step inequality that we had to solve in order to find out what p is all by itself, right? That's our whole point of solving, is we need to get the variable, the letter, by itself, so we need to undo any numbers around it. All right, turn to the next page. I'm going to have you give it a shot as well. So go ahead and try this first problem, pause the video, and then come back and see how you did. All right, check out this answer. So we're selling 5 plants, and we can spend more than $25. More than is going to be greater than. So some possible solutions. So I was thinking, well, what about if each one was $5? That would be equal to 25, but that's not good enough. I'm willing to spend more than that. So I could spend $5.50 for each plant. I could spend $6. I could spend $7. These would all put me above $25. So the algebraic solution, again, take my inequality. I'm going to solve it just like normal, so I'm going to undo that multiply by 5 by dividing on both sides. keep the same symbol, and I have p greater than 5. So I'm going to make one of my marks equal to 5. I'm going to put an open circle, and then we're going to shade to the right. Okay, I'm going to do this next one with you because it's a slightly different type of problem. So let's take a look at this. Janelle needs to save at least $60 to buy some new clothes. All right. Already we have a key word there, at least. We know that that is represented by greater than or equal to. So I'm going to start off and put that right in my inequality. Now we need to figure out what goes on each side. Well, she needs to save at least $60, so we know that, oops, didn't quite get that. We know that this side has to be 60. And here's what we know now, though. She has saved $10 so far, and we want to figure out how much more does she need to get the clothes she wants. So how much more? Again, we're going to call that D because we don't know. But she starts off with 10, and then we know that she's going to save some unknown amount, but she has to save so that she has at least $60. So let's think about possible solutions. I need 10 plus something to be equal to 60, so she could save an additional $50, and that'll get her to the 60. And then she can save any amount above that in order to stay above 60. So 51, 55. Maybe she does really well and saves another $60. That number got messy. All right, but let's do an algebraic solution to this. So I'm going to write my problem again. This is just a one-step equation. I need to undo this 10. Now this 10 is being added, not because of this plus, but because of this plus, this invisible plus that goes with the 10. So I have to undo that with a minus 10. I need to balance that out on this side. So that leaves me with D. Bring my symbol straight down. 60 minus 10 is 50. And this is where this graph really comes in handy, because I don't want a line graph that goes from 0 to 50. That's going to be pretty big. So I'm just going to mark this line. I'm going to call that 50. And it's greater than or equal to 50, so I'm going to put a big closed circle on it. Greater than or equal to means above, and above means shade to the right. Something like that. All right. So, the whole idea here is how can you translate these into a one-step equation and then solve them? And we're really going to focus on solving them algebraically. All right, let's go ahead and turn to the next page for some more practice. So these problems are some basic one-step equations and inequalities. And the idea, again, is just to give you some practice and show you how they are, how the technique is the same for both. So go ahead and pause the video, solve these, and then come back and check your answers. All right, go ahead and check these answers out. I think they're all pretty straightforward, except for number 5 and 6. So when you have a fraction, we're going to practice a more complicated version of this, but if the fraction is 1 over a number, you can treat this as a division problem. You could think of this as y over 2 equals 5. 1/2 times y is the same as y divided by 2. So that's why I undid it by multiplying by 2 to both sides, because these 2's will cancel. I'm left with 1y, which is the same as y, and then, of course, I have 10 on the other side. So just something to think about. We're going to talk about soon what to do if that fraction is more complicated, but not today. All right, go ahead and turn to the next page for some more practice problems. All right, for this first box, This is a matching exercise, but in order to match these inequalities with these graphs, you're going to have to solve them, and they're all little one-step inequalities. So you have to solve them first and then match the graphs. So for example, if I look at this first one, I'm going to have to do a +4 on both sides, right? So that's going to give me x greater than 7. And then I look down here and I see, there's an open circle starting at 7. So that one matches there. So I'm just going to draw a line down to show which one it matches with. Okay, I'd like you to match the rest of them, and I'd like you to do this multiple choice problem as well. So go ahead and pause the video and then work on those, then come back and check your answers. All right, go ahead and check these answers out. I think the one tricky one might be this equation, because you have to subtract 2 from both sides. So you're going to have 1 minus 2. So if I am at 1 and I have to subtract 2, remember this from first semester, we have to go to the left 2, and that takes us to -1. So that one might have been a little bit tricky. All right, and then this one wasn't too bad. We had the keyword at least, which means greater than or equal to. And so I had 50 to start with, plus an additional amount I need to save, and I need to save at least $80. All right, one more page of practice. Go ahead and turn to that, please. All right, just a couple of quick practice problems below. Go ahead and find these answers and come back and check your answers. Pause the video, please. All right, check out these answers. These are pretty straightforward, I think. Had to undo the 10 by dividing both sides on this one. Had to undo the 10 by multiplying both sides for this one, and here I just had to add 2 to both sides to get x greater than or equal to 2, closed circle above, so that's why that graph is the match. All right, let me know if you have any questions, and if you still have time left, you can work on your homework.